What we did was we shot a series of thermals, and I'll start running one over here on the left while we're talking. We ran water lines through the block cylinder and then the other block cylinder with a rod through it. And the water was ran up to 100 degrees Celsius. Then we cooled it down to 15 degrees Celsius. And we shot thermals of that. So this is almost heated to temperature. I'm going to let this one on the top left run while we talk, and we'll set up another test here. And you can see as it heats, this took place over about a half-hour period. And I apologize, there's a slight water leak on a bubbler tube I had here. And we had recorded last week all this information. This is a Vega V450 CM block cylinder, short stroke, heavy duty, 450 bar of pressure. And what I want to show you on this one is what's called a plot profile. And I'm going to draw a line across the part. And as I'm talking and doing this, you can notice in the top left corner, the cylinder rod is cooling and the block cylinder is also cooling. But the body is staying the temperature it was, whether it's hot or cold. This is all through conduction of the rod touching the seals and touching the actual components inside the cylinder. So if you can imagine, if you keep this cool, which you'll see it cool down as well as we go forward, it will stay cool, just like the actual cylinders. This is the block cylinder with the cooling channel in the front end here. I'm going to analyze this, and I want to do what's called a plot profile. And the plot profile I'm going to put below it. This is for this center one. I'm still letting this run. You can see how cool the rod is getting and the cylinder body itself. I'm going to turn this plot profile into live, and we're going to watch this one. So I'm going to pause this one for a moment so you don't get distracted. Hit play, and what's happening is you notice as the chilled water comes into the cylinder here, you should look how uniform the temperature is in the front half of the cylinder. The back half of the cylinder, you have hot hydraulic oil in the cylinder. There will be a certain temperature, but the whole point of this is that we maintain a uniform temperature. Now, when it's bolted to another mass, that influences this temperature, and that's why we pump water through to take away the BTUs. But if you notice how that works, this is pretty uniform here. Now I can pause this, and we can drag this plot profile around just to see what we're talking about for the temps. It's pretty interesting when you look at this. If we take this end up and we just look at a short profile, you can see it's pretty uniform. I'm going to click on this. The other thing that we can do, I'll shut down my plot profile, is we can do what's called a 3D surface plot. So if I say my, where is it at down here? 3D surface plot. So a 3D surface plot looks like the actual picture. See the picture above here? It looks like the actual picture. What's different is when you rotate it, it gives it relief, indicating that the brighter colors are higher temperatures, and it's just a graphic way where you can look at a 3D surface plot of radiometric data or thermal imaging data. It's a pretty cool way to communicate to someone who maybe isn't very technical what is supposed to be hot and what is supposed to be cold. Now I'm going to run another one of these videos here. I'll let this one run in the background. It's doing the similar thing. We've got a spot temp in Fahrenheit here. It's at 180 something degrees, and it'll continue to cool. But if you look at the front of these cylinders, and this will flip back over and you'll see it start to cool down. As you look at the front of these cylinders, you can imagine how much easier and how much longer of a life would be of the seals because you're maintaining the temperature. And you can see the effect on the right-hand side where the water is cooling down the cylinder. We'll pause that one. This one down here is just a straight picture. This is also just a straight picture, so we can shut these off. So I'm going to run this one. I'm going to go into the large mode here. We'll let it cycle back through. 100 degrees Celsius. Switching over to 15 degrees Celsius. And it gives you a very graphic image of how that will impact the overall temperature of the cylinder and the seals.